So we're going to start. Good afternoon, distinguished colleagues and guests. It's April 5th, the year 2022, 2 p.m. Moscow time. And we're beginning the panel session for the defense of the thesis by Artur Saakyan. The thesis is submitted for the academic degree of candidate of sciences in physics and mathematics. The specialization is 1-2 mathematical modeling, numerical methods, and program complexes. The topic of the thesis is algorithms and programs of high-precision computation problems in dynamics. Under the order issued by the Academic Secretary of St. Petersburg State University, Alexander Knyatov, as of January 24, 2022, number 36/7/1, I, Dmitry Ovsyannikov, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Control Systems Theory of Electrophysical Facilities of St. Petersburg State University, was appointed the chairman of the board. The order also approved the members of the board, namely Ekaterina Vinogradova, Doctor of Sciences in Physics and Mathematics, Associate Professor, Professor of the Department of Electromechanic and Computer Systems Modeling of St. Petersburg State University. Alexei Zhabko, Doctor of Sciences in Physics and Mathematics, Professor, Head of the Control Theory Department of St. Petersburg State University. The following members of the board are working remotely today: Vitali Milnikov, Doctor of Technical Sciences, Associate Professor, Professor at the St. Petersburg State Mining University. Vitali, do you see and hear us? I do. And Vanya Barsigyan, Doctor of Technical Sciences, Professor, Leading Researcher at the Institute of Mechanics of the Armenian National Academy of Sciences. And Professor of State University of Armenia. Yes, I see and hear you. Thank you. And our candidate for the degree today is Artur Saakyan. Levon Babajarnyans, Doctor of Sciences in Physics and Mathematics, Professor, Department of Controlled Motion of St. Petersburg State University, is the thesis supervisor. Unfortunately, he is unable to participate in our today's session. I would like to inform you that the panel session of the Dissertation Board is being recorded and broadcast on the St. Petersburg State University website, and it is also interpreted into English. Currently, we have an email address posted on the page with live broadcast of the board session, and all listeners can submit their questions to Mr. Saakyan online, the questions regarding the thesis or the content of the presentation or the scientific discussion. Thus, our listeners can participate in the discussion, and these questions will be forwarded to me by our technical service, and I will read them out during the discussion. The questions must be related to the presentation and the content of the thesis, and do not forget to give your name and position if you submit a question. The questions that have nothing to do with the scientific discussion or dissertation text, and also anonymous questions, will not be voiced. Under the order on the procedure of granting academic degrees at St. Petersburg State University approved by local regulatory acts, hereinafter the order, the session of the Dissertation Board is valid, providing 2/3 of the appointed board members are present. And the total number is not to be fewer than 4 people. The Dissertation Board consists of 5 people. Everyone is here today, including 2 members of the board working remotely. And we have a multimedia connection with them. Therefore, we have the quorum. So I kindly ask the member of the Department of Dissertation Board Support to fill out the attendance list. Our agenda today is as follows. We have 2 hours. So first of all, the chairman's presentation about the documents submitted by the candidate for the degree and their conformity with the requirements. The candidate's presentation providing an overview and findings of the research. 15 minutes will be given for that, followed by questions to the candidate regarding the presentation, no more than 10 minutes per question. The candidate's replies to the questions, 5 minutes for all. The reports on the thesis. The board members will be taking the floor in turns to provide their review and offers, 10 minutes each. Then the chairman's report on the thesis, 10 minutes for that as well. The candidate's comments about the reports on the thesis and replies to the questions, 20 minutes for that. Open discussion, speeches by those present at the defense, with a brief presentation of positions, of questions, of suggestions to the candidate on the topic of the research, 10 minutes per anyone willing to participate. And don't forget to state your full name, academic rank, position, and place of work in the registration list, and don't forget to introduce yourself when I give you the floor. Then the chairman will ask the questions submitted during the broadcast via our website. And I would like to draw your attention to the following fact. The written questions that will take more than 2 minutes to read out will not be voiced. Then the candidate's replies to these questions, 2 minutes per question. Then the presentation of the candidate's thesis supervisor, 3 minutes. Well, in this case, we don't have the supervisor, so I'll read the review. Then a 5-minute discussion before the open balloting on conferring or non-conferring the academic degree. The discussion of this results is not broadcast. Then open balloting, we're going to count the votes and record the results in the protocol. Afterwards, we're going to make a decision on whether to confer the academic degree to Mr. Saakyan or not. And finally, we're going to listen to the candidate's closing speech. 2 minutes will be given for that. So, distinguished colleagues, any objections or any questions about our agenda? Yes? No questions. Okay. As there are no questions, let us proceed. And before we do that, I kindly ask you to switch off the sound on your mobile phones. Thank you, and let us begin with the chairman's presentation. A thesis by Artur Saakyan for the academic degree of Candidate of Sciences in Physics and Mathematics, specialization 1-2, mathematical modeling, numerical methods and program complexes, is titled Algorithms and Programs for High-Precision Computation Problems in Dynamics. The thesis was approved for the defense by the order of the Academic Secretary of St. Petersburg State University as of December 30th, 2021. Order number 13199/1. Artur Saakyan has prepared his thesis at St. Petersburg State University as a postgraduate student, and his thesis supervisor is Levon Babajanyan. I have already introduced him. 4 published works describe the research findings of Mr. Saakyan, and all articles are published in journals indexed in Web of Science and Scopus. All the documents submitted by the candidate for the degree, as far as I'm informed, comply with the requirements of St. Petersburg State University and are kept in the certification file of our applicant and the curator of the defense. The member of the Department of Dissertation Board Support has all the copies of these documents. And before I give the floor to our candidate for the degree, I would like to ask the members of the board, distinguished members of the board, do you have any general questions to the candidate for the degree? Is there need to consider the whole list of documents submitted by Artur? No. None. No questions here. Well, as there are none, thank you, and let us proceed then. Artur, please, you have the floor. Distinguished members of the board, the topic of my thesis is Algorithms and Programs for High-Precision Computation Problems in Dynamics. Shortly about the content of my report. First of all, we're going to consider the system of differential equations in polynomial form. Afterwards, we're going to consider the recurrent formulas to compute Taylor coefficients, and after that we are going to discuss the schemes, introduce certain symbols and definitions needed to understand the overall problem. Then we're going to demonstrate numerical experiments to show the efficiency of our algorithms, and after that I'll have a general summary. So, differential equations in polynomial form. That's Cauchy problem. It looks like that, number 1. And let us shift to the construction of Taylor coefficients here. We're going to substitute formula 2 in the equality. Please pay attention to this equality. It turns out that one monomial is a derivative, is a product of two other monomials. And let's substitute equality 2 in this equation and in equation 1. So bring all the coefficients together, and after that equate them to 0. And as a result, we get the following formula, formula 3, that is a recurrent formula to calculate Taylor coefficient. What do we need here to use these formulas? First and foremost, naturally we need initial data. Cauchy problem should be formulated. Then coefficients before monomials. So all the right part, all the coefficients of the right part. And after that, the scheme. We need the scheme that is described in the end. And now let us discuss this scheme, what it actually is. So it stems from the fact that equality 2 was substituted in this equation when one monomial equals the product of two monomials, thinking that we already have this set from pairs of from couples of natural numbers. So let us introduce a few definitions for understanding then what monomial is. Expression 4 is a monomial, and the degree of monomial is the sum of degrees of variables represented here in this monomial. Afterwards, we're going to consider the set T, let's call it ordered, if this following condition 5 is met, and it provides for the growth of monomial degree. And after that, formula 6 will characterize our scheme. And the scheme is a set of pairs of natural numbers. And if we consider locally every pair, we're going to have monomial indices in our T set. And we will need to multiply them all in order to get the appropriate monomial. So formally speaking, we have a problem to calculate every next monomial in our set as a product of two previously calculated ones. So that's what scheme actually is. And extreme case, and the last definition that I wanted to give is a span. Just for us to understand what a span from monomials is that's an ordered set, but we understand that we may have a monomial that can't be calculated as a product of two previous monomials due to a degree or some other aspects. Therefore, we're required to introduce such a definition as a span. And the span here, if we don't read it up carefully, what's written here, and if we use some ordinary words, that's a set, a T set with added monomials that we need, that are sufficient for us to construct the scheme. So that is the basic, these are the basic definitions here and the basic symbols. And let's proceed. A simple example to consider here is an arbitrary set randomly generated. And here you see this T set. T set dash, you see this monomial x1, x2 of second degree that we need to add. And T dash will be a span for the considered monomial, for the considered T-set, because the T-set, you see, we have three monomials of degree 3, and we can't calculate them as a product of the previously calculated monomials, x1, x2, x5. These are all, they are all described by Cauchy problem. So we have the values, so we know them. And below you see the S set for the chosen sampling scheme S. Will look like that in the case. As I've already mentioned, natural numbers provide for the monomial index. Then we've considered this example, and let us consider a problem to invent a universal algorithm that would construct this scheme for an arbitrary set of monomials. The right part of differential equations here will be arbitrary, and we need to bear that in mind. And this problem was divided into two global problems. The first one is that we managed to bring up the problem to binary problem for programming, and here we have a restriction on the set that monomials achieve degree 3 and no higher than that. For the set of monomials of degree 3 and not higher, that's a binary linear programming problem, so that's global optimum here, therefore the problem is resolved here. And the formula for the scheme restriction imposed on every monomial and so on. And after that, I would like to fully expand the understanding of this algorithm, and we would like to have no restrictions on degree. So the next problem setting will look like that. Construct a span for an arbitrary set of monomials without any degree restriction. And this problem was something that we managed to combine. And here we combined a Grady algorithm with a previous binary programming problem. And we construct and decrease the degree by 1 on every iteration of this Grady algorithm. And we should bring the set to the problem that is described on this slide, to degree 3, and we know how to resolve degree 3 already. And in the general case, that's the local minimum. And for example, Intel problem that I consider here, that's a global minimum. But as for the general case, you can't say straight away. I did not prove any theorems here on global character, but basically you can find an example where it's not global, and in this case there is no need to prove any theorems or indicators. Then we need to show the efficiency of the provided algorithms. And one of the examples here is an body problem. And as we have polynomials in our right part, we should have polynomial components. We see degree -3 here. And therefore, let us introduce the replacement for variables. And in 2010, my thesis supervisor has published an article on the methods of additional variables, and there he gave a lot of classes for functions that could be reduced to polynomial form. I'm not showing it here. I'll just show the replacements that we'll need to make. This replacement 9 in equation 8. The system of differential equations 8 can be reduced to a polynomial system of degree 5, and 5 will be the maximum degree here in equation 10. Then the replacement 11 and 12 reduce everything to degree 4 and to degree 3 accordingly. Then if we have a model, we have certain proposed algorithm, then let us organize experiments and see whether it's expedient and how efficiently it's going to work. The first experiment organized was based on randomly generated monomial set, and I thought that, well, let's just generate monomials regardless of any problem, and let us consider the general case of efficiency. And efficiency here is demonstrated as we have two components here that play a role: the number of monomials and the number of variables that compose this monomial. So let's vary them. Let's give an increase and see what happens. And I introduce tau as an indicator that will be responsible for the efficiency of the scheme. And this will mean that we're going to find a relation of time of calculation of polynomial without schemes and divided by the time of calculation using schemes, and thus we're going to demonstrate the efficiency. And certainly this indicator should be higher than 1, otherwise that's too sad. The scheme is not efficient. And here we see that when we see a growth of variables, of monomials, and with a growth of the number of monomials in our set, the efficiency is growing. And for cases from 200 variables and 10,000 monomials, the efficiency is 7, and minimum is 5.7. That's okay, sounds well. Sounds good. So we understand that that's efficient for the random monomial set. And let's have a look at the real models. The real model is described here. That's n-body problem. And other two experiments here are dealing with n-body problems in different polynomial forms. And thus we demonstrate the efficiency of using these schemes. And on this slide, you see the efficiency of this transition to a polynomial system overall. You see T0. It means that our initial system is without any transitions to a polynomial system, and we see that the calculations in the right part as a polynomial give us an improvement in time, in machine time. That's the first step that we're going to demonstrate, that the shift to polynomial system has this role for calculation. And the use of scheme is demonstrated here. And n is an body problem from 3 to 10. And if the efficiency for calculation of the right parts is demonstrated, and we've already seen the recurrent formula to calculate Taylor coefficient, and we understand that the calculation of right parts is also reduced to the calculation of the right part in degree 4. So these experiments basically cover the importance of algorithms that were presented, and I will also given the numerical integration of differential equations and n-body problem in different forms. And I compared it with one of the implementations of Taylor set methods in tides, so-called tides. And we see that both in time, the minimum improves 2 times, and in errors, we are always better with that. Otherwise, that's basically it, what I wanted to mention, and shortly about the results of the thesis. 2 above-mentioned algorithms that were described here, they automatically construct the scheme, and I also provided the appropriate programs for automation, and also programs for automative configuration of the input data to describe the Taylor set method, represented by my thesis supervisor. And I also conducted numerical experiments that demonstrate the efficiency of using these algorithms previously described. That's it. Thank you so much. Thank you. Any questions, colleagues? So, colleagues who joined us remotely, do you have any questions? Artur? No? I have none. Me too. I have one. Once again, can you please specify this theory of additional variables was devised long ago, and this recurrent relation were described before you switched to them, and your major difference here from the work of Levon Konstantinovich and his colleagues. So what's this basic difference here? For the construction of, well, Levon has program implementation of the presented method. As input data, we need a scheme. And as a result, in the work that was published by Levon Konstantinovich, there is a paragraph there for the topic of the scheme, where he writes that the construction of scheme for the universal algorithm that would construct this scheme automatically, that's a separate field of study. And here, for n-body problem, we may construct them looking at the right part of the differential equations. And in the general case, it doesn't work like that. In real applied problems, the scheme construction may not be quite obvious. Therefore, we need to have algorithms that automate this process. That is why here the major contribution is represented by algorithms from the point of view of mathematics that construct the scheme automatically. The scheme that's needed for the input data to the method. And a program implementation that makes it all automatically. So, in fact, a method of Taylor's series of Levon Konstantinovich has two items that we want to automate. The first item is if I resolve an applied problem, it's not the fact that it's polynomial. Therefore, first of all, we should reduce it to polynomial form, and if I see the method efficiency, I want to use it for my project. And first of all, I need to reduce everything to polynomial form. And a PhD was defended by Bradman. I don't remember the year, but I attended the defense. And the second point is the scheme. We should automate the process because sometimes they're not obvious. And if you have a global optimum, you minimize the costs for calculations, and taking into account the fact that Taylor's series is characterized by coefficients for calculation. For a long time, they were not quite popular. Therefore, the conclusion, the automation of the entire process. Thank you so much. Yet another question. Did you integrate any differential equations directly, or did you just calculate monomials? Yes, I integrated them to n-body. And what's the degree here? The highest power. Oh, I don't remember. You don't. But maybe approximately, which did you test? Well, I had a 3-body problem here. Therefore, you see, the order was. No, I don't remember. I can't recollect. Yes. And in time, did it take long? Well, for time, I ended up a column. Sometimes I just launched it at night and checked whether I had results in the morning. And you see here on the slide the last 3 calculations that I integrated for 3 million days. And I didn't get a response from tides, therefore I did not add this data here. Thanks. Any other questions here? No, none. Okay. Now let us shift to the speeches of our dissertation board members. and maybe some external reviews if we had some. And I would like to remind you that you can answer the questions at once or after after all the reviews. So I can answer after all the reviews. Yes, I've already read them, so that's okay. Yeah, why not? Okay. Well then, Ekaterina, Professor Vinogradova, you have the floor. Well, I wanted to say that the relevance and the practical value of the topic, this thesis, is not questioned at all. Am I right? Because for contemporary science, taking into account the fact that we have more complex problems with more parameters, the time of calculations is quite decisive here. We all know that. Therefore, the scientific value and the novelty, and by the way, it was quite recently mentioned in response to your question, so that's not questioned. It's quite obvious. The credibility of results is demonstrated by the application of accurate mathematical methods in modeling and calculation experiments. And certainly there are some drawbacks. The first one being that there were certain misprints, but I believe the author has already corrected this misprints. That's the first thing. Second is that unfortunately you don't give the results of comparisons of calculations. And for me, special functions are of paramount importance because that's the mathematical set of calculations. And there's calculations that were presented in your thesis. Unfortunately, they were not compared to the well-known approximations of these functions. That's the second remark. But you see, these remarks do not compromise the overall high value of your work. And the major results reflect all the content points as well as publications. And in conclusion, I believe that the thesis by Artur, Saakyan, titled Algorithms and Programs for High-Precision Computation Problems in Dynamics, is a finished work that is quite novel and practically valid. We have options for practical implementation here, and the author described both real and statistical models formulated, and the thesis was written independently. It has unity and it contains novel results and provisions offered for the defense, and it demonstrates the contribution of the author to science. Therefore, I believe that the thesis meets the requirements of the orders of November 19th, 2021. That's the order 11181/1 on the procedure of granting academic degrees at St. Petersburg State University. And I believe that Mr. Saakyan deserves the academic degree of candidate of sciences in physics and mathematics and specialization, mathematical modeling, numerical methods, and program complexes. And Articles 9 and 11 of the above-mentioned order are not violated. Thank you so much. So, dear colleagues, I would like to remind you that as all the reviews were previously published on the website, you can follow suit of Professor Vinogradova and mark the basic remarks that you had. So, Alexei, please, you have the floor. Professor Zhavko. Well, the field of work and the thesis is defined by Levon Konstantinovich. So he's been developing this topic for a very long time already, and I believe that one of the main goals here was to fight for speed and accuracy. And here the details were already reported by Artur, and I would say that he divided his presentation in his construction into two parts: the construction of monomials before degree 3 and after that, or the spans and schemes. So I'll flick through the methods because you needed to apply different mathematical approaches here. And Artur mentioned that if in the first problem you manage to get an accurate optimum, in the second you're not always successful with that, but it's great when something is successful, something is not, when you have this division introduced. And in the last chapter, you conducted a good comparison of all these schemes. The tables were presented. And in different options, random ones and classical ones of n-body problem. I believe that you paid a lot of attention to n equals 3 problem. It's great with 2 and as for and 3, the problems are still there, you see. But still, you described everything in detail, and you carried out the comparison, and as you mentioned it in your work, that the proposed mechanisms work 2 times for n2 and higher, so that's the efficiency. And also, in this direction, I believe that there is still a way to go, but it's great that you're moving forward. And summarizing, I want to say that the topic is still relevant and still promising, and we have theoretical novelty and implementation, both for algorithms and for programs. And the conclusion, the basic results were already reported in sufficient number of publications. Therefore, I believe that the thesis by Artur Saakyan, titled "Algorithms and Programs for High-Precision Computation Problems in Dynamics," meets the requirements of the order as of November 19, 2021, on the procedure of granting academic degrees at St. Petersburg State University. And I believe that Artur Saakyan, our applicant, deserves the academic degree of Candidate of Sciences in Physics and Mathematics and specialization 1 to 2, mathematical modeling, numerical methods, and program complexes. And Articles 9 and 11 of the above-mentioned order are not violated. I have no criticisms on the content. Well, as for misprints, you know, they are just quite okay. And also, my signature is here as well. Okay. Our next speaker is Vitali Milnikov. Please, Professor Milnikov, you have the floor. Yes, distinguished colleagues. It was very interesting for me to read the thesis. And it is quite relevant, and the problem considered were quite important. I like the work overall, and it is, I believe, pretty good. And if you don't mind, I would like to shortly describe my review here, along with misprints that we have that characterize every work. My wish here that I wanted to give to the author is as follows. In subdivision 232, you consider the problem of n-body, and you give an example of a span construction for and scheme for problem 5 of n5 in different polynomial forms. And it would be nice to see a simpler problem with a smaller number of bodies. And the second point that I wanted to mention. In section 4.1, you demonstrate sufficient experiments, demonstrate the efficiency of schemes. And section 4.2 is associated with numerical integration of differential equations, but it would be nice to see more models here. Well, because examples, they always improve the results, make them more obvious, and provide us some demonstration, sufficient demonstration. And in conclusion, I want to say the following words. A thesis is a finished qualification study. It demonstrates the results that are valuable both theoretically and practically. The publications are quite enough in international journals as well. And I believe that the thesis by Artur Saakyan, titled Algorithms and Programs for High Precision Computation Problems in Dynamics, meets the requirements of the order as of November 19, 2021 on the procedure of granting academic degrees at St. Petersburg State University. And Artur Saakyan deserves the academic degree of Candidate of Sciences in Physics and Mathematics and specialization 1 to 2, mathematical modeling, numerical methods, and program complexes. And Articles 9 and 11 of the above-mentioned order are not violated. Thank you. Thanks. And our next member of the board is Professor Vanya Borsegyan. Distinguished colleagues, I will not read my review as it was already published, and I believe we should mention the following facts. Basically, the need in high precision calculation is something that was always with us, and currently it's quite obvious in dynamics problems. Therefore, the topic of the thesis is quite relevant. The thesis is based on the studies of Professor Babajanyan's. The author developed his approaches to develop computation algorithms and provided numerical calculation methods for ordinary differential equations, and thus he got theoretical and practical valuable results. The credibility and the validity of provisions is not questioned. The credibility of results is defined by strict mathematic problem setting methods and numerous calculations. A thesis is a finished study performed at high professional level, and certainly it gives us both theoretical and practical interest, and the results can be used in implementation of different calculations of ordinary and differential equations. And as for the text of the thesis, I had one remark. In section 2.3, you have numerous examples of scheme construction. And it seems to me that the first section, 2.1, 2.2, so these first sections are quite sufficient to demonstrate what you wanted. But certainly, this criticism does not influence the theoretical and practical value of the thesis. And in conclusion, I believe that the thesis by Artur Saakyan, titled Algorithms and Programs for High Precision Computation Problems in Dynamics, meets the requirements of the order on the procedure of granting academic degrees at St. Petersburg State University. And Mr. Saakyan deserves the academic degree of Candidate of Sciences in Physics and Mathematics in specialization 1 to 2, mathematical modeling, numerical methods, and program complexes. And distinguished colleagues, I wanted to mention yet another fact, that on the Department of Mechanics of Controlled Motion, we have a good tradition of training experts, and I spent my PhD course there as well. headed by Professor, and my supervisor was Professor Novoselov, and I'm really grateful to all the experts of the department, to Professor Babajanyans, who were always quite friendly to me, and I always had their support, and above all, I'm grateful to all the professors of the Faculty of Applied Mathematics and Control Processes, represented by the professors who are in the board. Thank you, everyone. Thank you so much. Thank you so much. So, dear colleagues, I'm the last one to read my review. What can I say here? The relevance was already described by colleagues, and everyone understands that Artur considered a very interesting problem, by the way, that was considered not for 1 century already, and Artur got significant results. And that's really nice. It's nice that on our faculty, and I would like to join in to support the words of Professor Saakyan, on our faculty, we did really have such young scientists, and that's really pleasant. As for the theoretical value, the novelty is that for the first time the algorithms for scheme construction for monomial sets in an arbitrary degree was presented, and the author formulated the problem and provided algorithms for quick calculation of different monomials with different variables. And the problem was reduced to the problem of whole number numerical calculation. That's an interesting result, I believe, and the basic results are described here in my review. I have 4 of them. Basically, I'm going to read 2 of them. So Artur formulated and presented an algorithm for scheme construction for arbitrary set of 3rd-degree monomials. The algorithm includes an approach of taking local optimal decisions at every step, permitting that final decision will be optimal. That's very interesting. And he also represented the numerical experiments for these algorithms that demonstrate the efficiency and the practical value, I believe, is something that everyone understands quite well. And I would like to add up that I listened to n-body problem. That's, a permanent problem. We have it and we will have it. And that's yet another problem of interaction of charged particles. And there we have the same equations, but particles, are numerous, infinite numbers of them. But the equations are just the same, and it will be nice to see. And as Alexei mentioned, here we may have a lot of other PhD works here, and by the way, we have many of them in the field, so maybe someone will dwell upon the topic, so it will be quite nice to hear. And as for the credibility, it was already mentioned, and as for the criticisms, in Chapter 4.2, you provide numerical experiments using n-body problem with 2 implementations for Taylor series. And it would be nice to see the comparison with more implementations of the method, for example, Martin-Bird's method. And you give reference links to Bird's works, but no comparisons are done here. But well, we know Martin Bird quite well, and he participates in many of our conferences, and he develops this Taylor model. That's not, exactly what you consider here, but maybe you may find some correlations here. And in conclusion, I would like to say that the thesis is a finished study, and it is practically and theoretically important. The results of the thesis were published in international journals indexed in Web of Science and Scopus. And in conclusion, I'd like to say that the thesis by Artur Saakyan, titled Algorithms and Programs for High-Precision Computation Problems in Dynamics, meets the requirements of the orders of November 19, 2021, number 11181/1 on the procedure of granting academic degrees at St. Petersburg State University. And Artur Saakyan deserves the academic degree of Candidate of Sciences in Physics and Mathematics in specialization 1 to 2, mathematical modeling, numerical methods, and program complexes. And Articles 9 and 11 of the above-mentioned order are not violated. and chair of the board, Doctor of Sciences in Physics and Mathematics, professor of the Department of Theory of Control Systems for Electrophysical Equipment of St. Petersburg State University, Professor Ovsyannikov. So that's me. And what comes next? What comes next? Just a second. Yeah, it's not as simple as that. So, anyone willing to comment on something? Oh, answers. Okay. Yes, until all these criticisms. Yeah. Well, I divided them into two parts. The first one's associated with chapter 2. And as professors have already mentioned, I had bulky examples. Well, I added it up. A 5-body problem. Well, bulkiness, yeah, I believe I could have taken this example out because in another chapter I bring them up to the polynomial system and to n-body problem in polynomial system, so I could do without it. That's the first cluster of remarks. And the second one was about numerical experiments and regarding 4.2, where numerical integration of differential equations. And we had offers to expand the models and solvers that resolve differential equations. And I agree with all the criticisms. Certainly, the work would be just more comprehensive if I would bear that in mind. So I agree with all these remarks. That's it. Okay. Dear colleagues, is everyone satisfied with the answers? Yeah, I am. Colleagues? Yeah, yes. Okay, great. Then, any speeches by the members of the board? Or maybe anyone willing to comment on something, or maybe any remote comments? None. No remote comments. Okay, if there are none, we take it that everything is going as we should and we should proceed. So, the speech of thesis supervisor. Unfortunately, he is absent today, and he submitted his review. And I can just say that Professor Babachanyan's we've known Levon for many years. We know how he deals with his PhD students, and certainly he does not allow those who are not prepared to go for the defense. So I won't read it all, I'll just read the major part. The thesis by Artur Saakyan is well structured, it has internal unity and is a finished and relevant, theoretically and practically important work. And Artur has demonstrated pretty good mathematical skills and knowledge of applied mathematics and programming that allowed him to generate valuable and important results. I believe we all agree with that. And I believe that the thesis by Artur Saakyan, Algorithms and Programs for High-Precision Computation Problems in Dynamics, is a finished study, and it meets all the requirements of the order on the procedure of granting academic degrees, and Mr. Saakyan deserves the academic degree of candidate of science in physics and mathematics and specialization 1 to 2. And yes, that was the review of Professor Babachanyan's. So, colleagues, anyone willing to comment on the work, members of the board, or anyone present at the defense? Anyone? None? No? No? Colleagues who joined remotely? No comments as well. Okay. Then, before we draw the conclusions, and before we vote, I would like to ask the members of the board and our applicant for the degree if there are any questions or remarks on the procedure. With the procedure of defense? No? None? Colleagues? No? No questions? No questions or remarks? Okay. Now let us switch to the next item on our agenda, the vote. So we have an opportunity to announce a break to discuss the results of the defense. And this discussion will not be broadcast. Or we can discuss everything openly straight away. How do you think? Do we need a closed discussion? No, no need for that. No, colleagues? No, no need for that. Okay. Okay, we continue. And we shift to the vote. And I would like to get your opinions publicly, all of you. So now it's 10 minutes to 3 on my watch. So I'll go step by step. Professor Vinogradova, I support this work, as I've already mentioned when I read my review. Okay. So, people may vote differently. Okay. Professor Zhabko, yes, I also support this work and vote for the award of the academic degree. Okay. Professor Milnikov, I also vote for the award of the academic degree to Artur. Professor Barsegyan, yes, I also support this work and I vote for the award of the academic degree to Artur Saakyan. And I, chair of the board, also support this work fully. That's a great work, I would like to say, and I liked it a lot. Therefore, no need to count the votes. Everything is clear. Distinguished colleagues and guests, I would like to announce that out of the 5 members of the board, all 5 voted for the award of the academic degree, no one voted against it, and no one abstained from the vote. Thus, the decision, we decided to award the academic degree of candidate of sciences in physics and mathematics in specialization 1 to 2 mathematical modeling, numerical methods, and program complexes to Artur Saakyan. And the finalizing remarks by our candidate for the degree. Well, I would like to thank the members of the board for the time they spent on my thesis, and I really appreciate it. And I would like to thank my thesis supervisor for his incredible contribution to me as an expert, for the right direction set in science and in my specialization. And I would like to thank my parents for their support that they rendered me for all these years. And I would like to thank my friends who came here and who are watching the broadcast online. And my colleagues, they are watching the defense as well. Thank you, everyone. Well, the microphone. Yes, okay, I beg your pardon. Well, I believe we'll be unanimous if we all give a hand to Artur and congratulate him. That's brilliant work, and I wish you all the success in your future studies, and not in in the studies only. Thank you so much. Thank you. That's it. Dear colleagues, therefore we